Hi everyone. Now we are at eigenvalues and eigenvectors, lecture number 12. So in the last lecture, problem number 2, this I have done by keep on finding the required terms a power 6, first a power 2, next a power 3, next a power 4, next a power 5, after that a power 6, right? We can do this one in a second way also, that I will do now. So characteristic equation, we got lambda square minus 4 lambda plus 5 equal to 0, right? So from here I will continue. Second method, we will do like this also, the same problem. First, by Cayley-Hamilton theorem, Cayley-Hamilton theorem, on the square matrix A satisfies its characteristic equation, therefore A square minus 4A, right, plus 5 times I identity matrix equal to null matrix. Okay, and from here we computed what is A square, right? So A square is equals to 4A minus 5 times identity matrix, and if you multiply both sides with A, you will get A cube is equals to 4A square, okay, minus 5A, and again if you multiply with one more A, you will get A power 4 is equals to 4A cube, right, minus 5A square. Next, and if you one more time, if you multiply with A, we will get A power 5 is equals to 4 A power 4, A power 4 minus 5 times A power 3, and if you do one more time with A both sides, multiply with A both sides, then 4 A to the power of 5 minus 5 A to the power of 4. Okay, so from here what I will do is what is the required one, and this one I want, right? What is this value? Then rewrite that A power 6 minus 4 times A raised 5 I want. Then what you have to do is simply substitute all these values. A power 6 value is 4A to the power of 5, 4A to the power of 5 minus 5A to the power of 4. Okay, this is A power 6 value. A power 6 value. Next, minus 4 times, what is A power 5 value? A power 5 value 4A to the power of 4 minus 5A to the power of 3. Okay, here. Next, plus 8A to the power of 4. So, plus 8, 8 to the power of 4 value from here. This one, what is this? 4A power 3. 4A power 3 minus 5A power 2. Next one, minus 12A power 3. What is A power 3 value? 4 times A power 2, okay, minus 5 times A. Next, plus 14 A square. 14, what is A square? A square value is 4 times A minus 5 times identity matrix. So next, you simplify this, you will get in terms of A power 5, right? Again, A power 5, A power 4, like that. Again, A power 5, you substitute this value, A power 4, A power 3. And next, A power 4 value, substitute this one. Again, A power 3, again, A power 2, again, simplify. Again, one more substitution. Like that, you keep on simplify until you will get a simplified term. Okay, you take this one as exercise, keep on substitute. This is second method. And third method. Next, third method. Method number 3. Third method. First, what is the blank question? So we want the value of A power 6 minus 4A is 5, right? And what is the fundamental equation here? That means the square matrix A satisfies its own characteristic equation, right? And that characteristic equation is A square minus 4a plus 5a equal to this characteristic equation. So from this, what is a square? A square is 4a minus 5a. This is check once. A square minus 4a plus 5a. A square minus 4a plus 5a. Yeah. So keep this one in mind, then we'll simplify this one. So now this is equivalent to, so observe carefully. So I need to generate these terms, 3 terms here. Let us take a power 4 common. If you take a power 4 common, then a power 4 I am taking common. Okay, so a square, from here look at a square, and a power 4 is out, minus 4a. Look at I am getting the same liquid terms, so get minus 4a I am getting next. A power 4 is out here, so 8i, so plus 8i, but here only 5i I want. Then later I will adjust these terms. Okay, minus 12a cube, okay, plus 14a square. Yeah, next step. So a power 4 a square minus 4a. Look at carefully. So in this I don't want 8i. What I want according to this? According to this I want only 5i. If 5 is there, then I will write this entire 3 values is null matrix. So then I am writing this one as 5i plus 3i. 5i plus 3i plus 3i. But 3i into a power 4, 3a power 4. That I am writing outside. 3a power 4 I am writing outside. Understood? 8i I am writing as 5 plus 3. 5i plus 3i. 5i only I am writing inside. Extra 3i is there, right? The 3i plus a power 4, 3a power 4. 3a power 4 I am writing outside. Next, what are left? Minus 12a cube. Okay. Plus 14a square. Then this will be, by K-linearity theorem, this is 0. No, sorry, not 0, null matrix. So this 3 values is null. A square minus 4a plus 5a. Look at here. A square minus 4a plus 5a is 0. It is over. Next, what is left? These 3 terms are left. Again you take common. 3a square you take common. Take 3a square is out. You get a square. Isn't it? 3a power 4. And next minus 4a. Check once 4 is 12. Minus 12a cube. Look at minus 4a. Next 5a I want. So 3a square, if you take, let me write 5i. If you are writing 5i, what does it mean? Indirectly 15a square you are writing, but here only 14a square, so minus a square you write extra. Understood? If you simplify this, you have to get this step back. And then simplify 3a square into a square, 3a power 4, 3a square into minus 4a minus 2a cube, 3a square into 5a, 15a square, but here 14a square, but minus a square are done, adjusted. Now this will be a power 4 into null matrix is null matrix, that is 1. So 3a power 4, 3a power 4 into again this is null matrix, this one, by K-linearity theorem. So 0, and finally what is left? Minus a square. So therefore this is finally it is minus a square. Okay, so that is, what is a square value? 4a minus 5. So minus a square value 5a minus 4a. 5a minus 4a. That's it. So like this also I can calculate. And moreover, so this expression is said to be linear expression. Linear form. And this is called non-linear form. Non-linear form. Non-linear form. Why the word non-linear? Because square is there, right? If degree is 1, that is called linear form. 4a, a power is 1. So this is linear form. This is non-linear form. Both are correct. So this is about third method. Next one. Today's class, quadratic forms. Okay. Definition first. Let A denote an n by n matrix. Look at this. A denote an n by n matrix. That means it is a square matrix with real entries. The entries are only real numbers. And one more matrix. This is column matrix. X denote n by 1 column vector or column matrix. n rows and one column. Okay, two matrices. Then the quadratic form Q is defined as Q is equal to X transpose. X transpose means it is a row vector now because X is column vector. X transpose is row vector. Row vector into the given matrix A, which is of order n by n, into again column vector n by n vector. These three togetherly with multiplication is said to be a quadratic form. How it will be? Look at this. So therefore Q is X transpose A into X. X transpose X is column vector. So X is column vector. How it looks like? Since it is a column vector, X will be like this. How many components? Total n components. So start with x1, x2 and up to so on. The last one is xn because it is n by 1 matrix. Okay, it is n by 1 matrix, n rows and 1 column. So this is X. Now X transpose, right? First I want X transpose. X transpose means n one row, n column, one row. So this is one row and n columns. First column, second column, up to so nth column. So this is X transpose, and this is matrix A, n by n matrix. So its order is n by n. So let me write here. So this is n, one row, n columns. Okay. Next one, matrix A is of order n by n. So this is 1 by n, and this is n by n. Okay, and this is n rows, one column, n by 1. This is x, right? X. So now this multiplication. So 1 by n into n by n. Now the resultant is 1 by n. 1 by n into n by 1. So resultant is 1 by 1. One row, one column. Only single entry you will get. That entry is this. So this is a11 into x1 square. Multiply these three matrices, you will get this expression. This entire expression is single expression. Okay, up to an xn square. So this expression is said to be quadratic form of the given matrix, a square matrix A. Okay, let us do some modifications in that matrix A. Now I am defining new entries Bij. So this is new entries Bij. How I am defining Aij plus Aji. For example, I is equal to 1, j is equal to 2. If I is equal to 1 and j is equal to 2, then what it becomes? A12 plus A21 by 2. And this should be what? B12. So B12 is defined like this. A12 plus A21 by 2. In general, what is A12, A21? For example, let us look at 2 by 2 matrix. This is A11, A12 and A21, A22. Okay, now A12 means this one. This is A1, A12. Next one A21, A21 means this one. So A12 plus A21 by 2. Then, for example, if this A12 value is 2, this A21 value is 4, then what will get? 2 plus 4 by 2 means we will get 3. We will get 3. Now B12 value should be 3, like that. Okay, so once B12 value is 3, so this is B12 value, right? So B12 value is 3. What about B21 value? Reverse. B21. B21 means I am taking I is to j is 1. If I is to j is 1, I is to j is 1, this is A21, A12. A21 plus A12. Again by 2. Again what is this? Same story. 4 plus 2 by 2. Now what will you get? 3 only. So now B21 value 3. So B123, B213. Indirectly the new matrix, observe carefully. Now the new matrix B is defined like this. So what is this? It is B11, B12, B21, B21, B22. In this what I am getting? B21 is 3. So this value is 3. So this value is 3. And B12 value also 3. Indirectly these two are entries we are getting same. Indirectly it is some sort of symmetric matrix, right? That's what. So therefore the quadratic form can be written as then the matrix Bij is symmetric matrix. So we are modifying the given matrix under this condition. So this condition, so that the matrix is becoming symmetric matrix. And the corresponding quadratic form will be like this: X transpose B into X, where B is symmetric matrix. While doing problems, you will understand this very clearly. Don't worry about this kind of symmetricity and how we are making symmetry like this. Okay, but you remember this one: X transpose A into X. X transpose is a row vector. A is a given matrix, and A is a column, x is a column vector, multiply all these three matrices, you'll get one expression. This expression is said to be quadratic form. And what is the use of this quadratic form, I will tell you in the coming context. Okay. Next one. Let us do one problem based on that definition. Find the quadratic forms associated with these two matrices. Okay. Now let us do first one. I want quadratic forms. First one. The given matrix A is, which is of order 2 by 2, 1, 4, 2, 1. Okay. Now its quadratic form I want. Know the quadratic form, and also write, let, we need to define one column vector x. Since it is 2 by 2 matrix, you take x as x1, x2 you take. Your wish, x, y also you can take. Okay. You can take x and y also. Or you can take x is equal to small x and small y. The only thing is 2 by 1 order matrix you have to take. Only column matrix you have to take. That's it, nothing else. Okay. Either this or this you can take. So therefore, x transpose into A into x. This is called quadratic form by the definition. Now what is x transpose here? X transpose is, it is a row vector x1, x2, x1, x2. This is x transpose. And after that, the given matrix is 1, 4, 2, 1. I will tell you the applications of this quadratic form at the end of this concept. But just you know what is mean by quadratic form and how to construct quadratic forms. So next, x means it is a column vector x1, x2. Now let us multiply these three matrices. So this is of order 1 row 2 columns, right? 1 row 2 columns. This is 2 rows and 2 columns. This is 2 rows and 1 column. Does the matrix multiplication is possible? Yes. Look at here 2 columns and here 2 rows. Therefore, this matrix multiplication is possible. Let us multiply now. What will get? So what is the order? 1 by 2. 1 row 2 columns you will get, right? x1, x2 with this column. 1 into x1 is x1 plus 2 into x2. This is first entry. 1 row 2 columns will get. So this is first entry. Next entry here with the second column 4x1 plus x2 over. What its order? This order is 1 by 2. Look at resultant matrix order is 1 by 2. So 2 is out, 1 by 2 I got. So this matrix multiplication is over. Next, left with this one, right? x1, x2 is not over. Now we have to multiply with this matrix, column matrix. Now let us multiply. So this is 1 by 2 and what is this? 2 by 1, right? Now resultant matrix order should be 1 by 1 now. 1 by 1 means only one expression. Let us write that. What is that? So x1 plus 2x2 into x1, right? So x1 into x1 plus 2x1. Okay. Next, plus 4x1 plus x2 into x2, like this. Okay. Now this will be multiplied. x1 square plus 2x1 square plus 4x1 x2 plus x2 square. So this one, this is 2x2, right? So this is 2x2. So this is 2x2 square. This is x2 square. Let me write clearly this one. This is x2, 2x1, x2. Now simplify. So x1 square plus 6 times x1 x2 plus x2 square. Okay, so this is called quadratic expression for the given matrix A. All right, and next one for second matrix 1 2 1 continuation. for the second matrix. One, two, one, 2 minus 1, 3, 2 minus 1, 3. Next, last two, 1, 3, 4. 1, 3, 4. This is a given matrix. Matrix A it is. So then let, what should be x now? You take the column vector. Since it is 3 by 3, 3 by 1 matrix you have to take x1, x2, x3 you can take, or simply x, y, z you take, your wish, whatever. The only thing is 3 by 1 order matrix you have to take. So therefore by definition, what is x transpose? The quadratic form is x transpose into A into x is equals to x transpose x1, x2, x3. This is row matrix because x is column, x transpose is row matrix. Next, matrix A 1, 2, 1, 2 minus 1, 3 and 1, 3, 4. 1, 3, 4. Okay. The next one, column matrix x, that is x1, x2, x3. Again same story, multiply first these two, or you can multiply these two first, your wish. Then multiply x1 into 1, so x1. So what will you get? This is order is, its order is 1 by 3, 1 row and 3 columns, and this order is 3 rows and 3 columns. Now the resultant matrix order is 1 by 3, 1 row and 3 columns. So x1 plus 2x2 plus x3. This is first entry. Next entry is 2x1, okay, plus minus x2 plus 3x3 plus 3x3. Okay, and last one is x1, last one this row and this column 1, 3, 4. Okay, x1 plus 3 times x2 plus 4 times x3 times x3. So this is the matrix of order 1 by 3, 1 row 3 columns. So this is 1 by 3. This matrix order no need to write, just I am explaining for better understanding. And here, and column vector is x1, x2, x3. And what is this order? 3 by 1. Okay, so it is of order 3 by 1, 3 rows and 1 column. Now resultant matrix order is 1 by 1. So now finally 1 by 1, so one expression. So x1 plus 2x2 plus x3 into x1. So x1 into x1 plus 2x2 plus x3, okay, plus x2 into 2x1 minus x2 plus 3x3, okay, plus last one x3 into x1 plus 3x2 plus 4x3. So single 1 by 1, so only one number. So x1 square, okay, and plus 2 times x1 x2. Next one, look at this is x2 x3, x2 x3, same terms. So total 6. So 6 times x2 x3. Okay, that's it. So this is finally quadratic expression with respect to the matrix A. Okay, next one. So one observation you have to do here, the observation is, look at here, in this, look at this entry a11 into x1 square. X1 square is nothing but, I can write this is x1 into x1, right? X1 into x1, indirectly this is a11 coefficient. Okay, x1 square. So this is a11, whatever. For example, 2x1 is there, 2x1 square. That means this 2 is nothing but a11. Like this you have to remember. And here x1, x2, right? x1, x2 is nothing but a12 coefficient it is. a12 or a21, whatever. a12 or a21 or A21. Like this, you can construct back the matrix. So this is quadratic expression. How to get matrix from reverse like this? So now look at, for example, x3, x4 coefficient. For example, you're having like this 4 into x3, x4. Meaning is x3, x4 means A34. A34 means third row, fourth column entry will be 4. Or A34 or A43. A43. Like this. So togetherly A34 plus A43, the sum is equal to 4. Look at the sum is equal to 4. We can construct back like this. That is problem number 2 or problem number 2. I will do in detail. Don't worry. For example, look at here for this problem. X1 square means x1 into x1, right? That means A11. So its coefficient is 1. So A11 is 1. Look at this is A11 is 1. What is the entry? A11, A12, right? Next A21, A22. Okay, so this is a matrix. Now A11 we got. What is that? A11 is from here is 1. Nothing is there means here 1. So 1 into. So this is 1. So this entry is 1. Next, x1, x2 means what here again? x1, x2 means A12 plus A21. And this value how much? 6. So this, so sum of these two, right? So this one plus this one togetherly, sum of these two is 6. So sum of these two is 6 means it can be 2, 4. 2 plus 4 or 3 plus 3 or 4 plus 2 or 1 plus 5 or 5 plus 1 or minus 1 plus 7 or 7 plus minus 1. So many ways we can write. Okay. So therefore the matrix representation is not unique. The quadratic expression is unique. So if you give me this matrix, one and only one expression, that is this one only. But if you give me this expression, so many matrices we can generate. In that matrices, this is one of the matrix. Understood? So matrix representation is not unique. Only quadratic expression is unique. That we will know, getting to know in problem number 2. Look at problem number 2. Find the matrix associated with the quadratic form, this one. Okay. Look at particularly for this problem. Solution. So Q is given to us, which is x square plus 3xy plus y square. I want matrix A. Okay. So now matrix A is simply A11, A12, A21, A22. Why I am taking only 2 by 2 matrix? Why? Because look at here. You go back the problem number. Look at here. This problem. Here we are getting. Look at 3 variables we are having x1, x2, x3. Right? How many variables in this expression? 3 variables. That means it is a 3 by 3 matrix quadratic expression. If you look at the first problem, you are having here only 2 variables x1 and x2 in this expression. Look at in this expression only x1, x2 you are having. That means it is 2 by 2 matrix quadratic expression. So in the same way, so in this problem number 2, how many variables are there? X and y. 2 variables are there. Therefore, it is 2 by 2 matrix quadratic expression. Okay. Now we need to find A11, A12, A21, A22. Okay. Now x square coefficient is 1. X square is nothing but x into x or simply x1. See, you look at here, x means first variable. Okay. Y means second variable. Now if I write x square, what does it mean? X into x. X into x means what? First variable and first variable. That means it is A11 coefficient. 1 first variable, 1 first variable. So x square coefficient is nothing but A11. X into y. For example, if you are having x into y, that means x is first variable, y is second variable. So x into y. So first variable, it is second variable. That means it is A12 coefficient. X into y. So nothing is there means here 1. So this 1 is nothing but A12 plus A21. Okay. Similarly, x means first variable, y means second variable. Now first variable into first variable means A11. So A11 coefficient is 1. Okay. So therefore, the matrix representation is A11. X square coefficient is 1 here. So 1. Next A12, A21. A12. A1 means x. A2 means y. A2 second variable is y. So xy coefficient how much here? 3. So therefore, A12 plus A21 will be how much? 3. How to remember? I am telling you, that's nothing else. So sum is 3. So this sum is 3. Therefore you can write 2 1 like this. Or you can write year 1 year 2. No problem. All are correct. Okay. Next a22 means a2, that means y into y, second variable into second variable, y square coefficient it is. What is y square coefficient in this expression? 1. So therefore it is 1. Now let us take this matrix. Let us go back. Verify whether it is right or wrong. Verify. Or simply verification. Let us go for the verification. Verification. It's not required, just I am verifying. Look at. What is given first? Quadratic expression is x transpose into a into x. So x transpose, so xy you take variables are x1, y1, but according to problem, two variables are x and y, and the given matrix is 1, 2, 1, 1, okay, and here xy. Let us multiply now. So this will be x into y and this one, x plus y, next 2x plus y, 2x plus y. So 1 by 2 matrix, 1 row, 2 columns into x into y, one more time multiplication. Multiply x into y into x, so x into x plus y, okay, plus y into 2x plus y. So this will be x into x, x square plus xy, like this is 2xy plus y square. So now this will be x square plus 3xy plus y square. Look at, verified. This is quadratic form. Look at quadratic expression. So you can take like this, or you can do one more way also. This is one, or one more matrix is this diagonal index will not change, but only changes is this one only, a12 plus a21. Look at this, a12 plus a21 is 3. Then such combinations I can take, right? So here you take 4, here you take minus 1. The only thing is I want sum should be 3. You take this matrix and verify once again. You will get again same x square plus 3x plus y square. Or you can take like this also. Or you can take 2 by 1 matrix as, so 1 1, this does not change, so 3 by 2 you take here, 3 by 2, 3 by 2. Now you have to concentrate here. Index what I have taken, sum is 3, so half of I have taken. So what is the half of 3? 3 by 2. 3 by 2 plus 3 by 2 is nothing but 3 only. 1 and half plus 1 and half is 3. Now this is symmetric matrix. That's what in the definition, what I have taken, Bij is equals to, Bij is equals to, I'm defining it is like Aij plus Aji by 2, right? Just now I told you in the definition. Same thing I have done. What is Aij plus Aji by 2 is nothing but 3 by 2. Now Bij values are 3 by 2 here. If you take Bij values are like that, then the corresponding matrix B is equal to Bij will be symmetric matrix. Look at now, this is a symmetric matrix. I think you understood now. So if you take such kind of entries like this, then you will get a symmetric matrix. Now such a matrix is unique now. If A is a symmetric matrix here, x transpose A into x, if this A is symmetric, then one and only one matrix exists. If you don't keep any conditions, then what are the possibilities of A? For this problem, look at 3 possibilities I found. Not only 3, you can write here 5, you can write here minus 2. So 5 minus 2, 3 you will get. That is also one matrix. You can write 6 minus 3 here. Here 6, here minus 3. Like that you can generate so many matrices. Therefore such A is not unique. But if you take A is symmetric, then the matrix is unique. So that you write in the note. So therefore note in x transpose A into x, if A is symmetric, if A is symmetric matrix, then A is, then only A is unique. Such A only one matrix exists if A is symmetric matrix. Otherwise, this A is not unique. You can write like this so many matrices. I hope you understood this. Next one, same way, problem number 3. Look at this. Find the matrix associated with the quadratic form. This one. Here 3 variables are there. So therefore, it is 3 by 3 matrix quadratic form. Okay. So therefore, now let us write directly. So matrix A is, yeah, let us write A11, A12, A13. Okay. Next, the given quadratic form Q is 2x1 square plus 3 x1 x2 plus x2 square plus 2x1 x3, next plus x2 x3, x2 x3 plus x3 square. Okay, now here we need to find out the coefficient. Look at this, is x1 square means x1 into x1, right? Look at, I'm explaining here. X1 square is nothing but x1 into x1, x1 into x1. That means indirectly this is a11 coefficient. Its coefficient is a11. So therefore x1 square coefficient is 2. Therefore a11 value, is 2. So therefore this entry is 2. Okay, let me write here itself. So I am writing here it is 2. First entry is over. Next, now what is this? I want a22. A22 means x2 into x2, x2 square. x2 square coefficient is 1 here. So therefore let me write first diagonal entries 2 1. Next this is a33, x3 into x3, x3 square. x3 square coefficient how much here? 1. So here is 1. So diagonal entries are over. Okay. Next non-diagonal entries we have to calculate. Look at this, is a12 plus a21, a12 a21. Now what is a12 a21? x1 x2 coefficient, right? x1 x2. So x1 x2 coefficient, x1 x2 is nothing but a1 a2 plus a2 a1, whatever, because here x1 x2 or x2 x1 both are same, right? x1 x2 or x2 x1, that's why a1 a2 plus a2 a1 by 2. So this later I will construct. So before that, a1 plus a2, a1 a2 plus a2 a1, this value how much here now? Is nothing but x1 x2 coefficient. What is x1 x2 coefficient? 3. So this value is 3. But if you want to generate this one as a symmetric matrix, then by 2 I have to take, right? So if you take by 2, what will you get? 3 by 2, 3 by 2. So you take this entry is 3 by 2. If you take this entry is 3 by 2, you take corresponding this entry also 3 by 2. Now look at 3 by 2 plus 3 by 2 how much? Look at a12 plus a21 should be how much? 3. a12 plus a21 should be 3. Now add these two, 3 by 2 plus 3 by 2 is 3 only, satisfied. Next look at a13 a31. Look at this one, a13 a31. a31 means x1 x3 now. So x1 x3 now, x1 x3 is nothing but a1 a3 plus a3 a1. Sum of these two coefficients, sum of these two expression is how much? That means x1 x3 coefficient here, x1 x3 coefficient is 2. So this is 2. Sum of these two is 2. That means what is the possibility of what is the possibility of these two entries? So this is a12. So sorry, expression is this one. What I need to write here is same thing only, but we have to precise. a12 plus a21, like this you have to write. Okay, a12 plus a21. Similarly here also same. Instead of writing like this, you have to write like this, a1 x1 x3. So a13 plus a31. Sum of these two is nothing but x1 x3 coefficient. x1 x3 coefficient is 2. So sum of these two entries, so a13, look at here, a13 plus a31, sum of these two is 2. You can write 1 1. You can write here 3, here minus 2, you can write, no problem. But I am dividing by 2. If you do by 2, then you get 1 and 1. So So simply you give half and half. Okay, this is 1 and this is 1 over. Next, these two entries a2 3. So x2 x3 now. Next one x2 x3 means again what is this? A2 3. 2 and 3. Look at index 2 and 3. 2 means second variable, 3 means third variable. Look at second variable and third variable. Or plus third variable into second variable, whatever. That is true. Product is true. Now what is this sum? Again x2 x3 coefficient. x2 x3 coefficient here is 1. So therefore this sum is 1. This sum is 1. Now let us divide by 2. We will get half and half. So therefore this is 1 by 2. This is 1 by 2. So therefore this is a required matrix. Take this matrix and you find the quadratic expression. Exactly you will get this one. Exactly you will get this one. And this matrix is symmetric matrix. Check once 2 3 by 2 1. Look at 2 3 by 2 1. And 3 by 2 1 1 by 2. Look at 3 by 2 1 1 by 2. 1 1 by 2 1 1 1 by 2 1. If A is equal to A transpose, then this is called symmetric matrix, right? This matrix is satisfying this condition. Therefore, this is symmetric matrix, and this matrix is unique. Or you can give like this also, or one more. Now this is not symmetric matrix, so the diagonal entries will not change. What are the diagonal entries? 2 1 1. And now what is this? Sum of these two, how much? A12 plus A21 is 3. So therefore 2 1 I can take. 2 plus 1 is 3. Or you can take here 3, here minus 1 I can take, your wish. Next, sum of these two, one A13 A31, A13 A31 will be, look at here, 2. So 2 means here I can take 2. Okay, here I will take 2, here I will take 0, my wish. 0 plus 2, 2 only. Look at 8, A23, right? It is A13 plus A31 is 2. Sum should be 2. Look at, I can take 0, no problem. Next one, next A23 plus A32 sum is 1. So these two sum is 1. So therefore I can take here 1, here 0, my wish. You can take this matrix and find out quadratic expression. We will get the same again. Or you can find one more matrix also. Like that you can generate so many, but in that the unique matrix is only symmetric matrix. This kind of matrix, only one matrix exists. Okay, so this is about matrix representation of the given quadratic form. Next one, some nature of the quadratic forms or classification of the quadratic forms. Look at here. Let Q is X transpose into A into X be a quadratic form associated with the matrix A. Okay. Then first one, positive definite. Positive definite. What is the positive definite? A quadratic form Q is said to be positive definite if the quadratic form is more than 0 for all x not equal to 0. X is a column vector here. This x, look at, this is x. X is a column vector here. X not equal to 0 means what? Here it means, for example, if it is a 3 by 1 matrix, so let us write 3 by 1, let us write x1, x2, x3. If it is a 3 by 1 matrix, and this is not equal to 0 means what? Non-zero matrix means x1 not equal to 0, x2 not equal to 0, x3 not equal to 0. Not like that. 1 to 0, it is not equal to 0. When it is equal to 0, if all are 0, then only this is 0. Then this is 0. But this one I don't want. All this kind of matrices, right? Non-zero matrix. If any one of the entry is non-zero, then this entire matrix X is non-zero matrix. So for all x not equal to 0, such matrices, such column vector, for such column vector, Q should be more than 0. Then such expression is said to be positive definite. Okay. Similarly, second one, negative definite. So a quadratic form, let me make it clear. This is same only, x not equal to 0 belongs to R only, so not to confuse. A quadratic form Q is said to be negative definite if Q less than 0. Again same for all x not equal to 0. Okay. Next, why I am writing here Rn? I have written Rn. Rn means n component should be there in x. See, look at particularly here 3 components I have taken. Therefore, this is belongs to R3. I can write R3 like this, because this matrix having 3 components, so it is 3-dimensional. So therefore belongs to R3. But here I have taken Rn because A is n by n matrix. If A is n by n matrix, X should be n by 1 matrix. N by 1 means n entry should be there. That's why it belongs to Rn I have written. Okay, make it clear everything. Okay, so this is negative definite if it is less than 0. Next, third one, positive semi-definite. It's some sort of A only, positive definite, it is positive semi-definite. What is the positive semi-definite? A quadratic form Q is said to be positive semi-definite if Q more than or equal to 0. Extra condition is, here is Q more than 0, here extra equal to 0 will hold. For all x and Q is 0 for some x not equal to 0. For some x not equal to 0 exists, at such vector x, quadratic form becomes 0. If this is also happening, then such quadratic form Q is said to be positive semi-definite. If it is always more than 0 for all values of x which are non-zero, then that is called positive definite. Okay, all these are some classifications. Next, negative semi-definite. Same story again. A quadratic form Q is said to be negative semi-definite if Q less than or equal to 0 for all x and Q is 0 for some x not equal to 0. Next, indefinite. A quadratic form Q is said to be indefinite if Q more than 0 for some x and Q less than 0 for some x. That means it is taking both positive values and negative values. Then such expression Q is said to be indefinite. So all these are 5 classifications. First one is positive, next negative definite, positive semi-definite, negative semi-definite and indefinite. So now let us do some problems related to this classification. Problem number 4. Find the nature of the quadratic form associated with these matrices. Look at the first one. I want the nature of the quadratic form. So before that I want what is Q, right? So let us take this matrix is 1 1 1 5. Okay, first one. So therefore what is quadratic form? And let x is, since it is 2 by 2, you have to take here 2 by 1, x1 x2 or xy, you can take your wish. Then you generate the quadratic form x transpose into ax. This is quadratic form. Now what is x transpose? x1 x2 is the row vector x1 x2. After that the matrix A is 1 1 1 5 plus 2 x1 x2 plus 5 x1 x2 square. Now go back, look at x1 square means it is a11 coefficient 1 only. Look at a11 is 1. Next, x2 square means x2 into x2, a22 coefficient is 5, a2 value is 5, so this is a22 value 5. Next, x1 x2, a12 plus a21 is 2. Look at a21 plus a12 value is 2, 1 plus 1 is 2, verified. So this is the correct quadratic form of the matrix A1115. Then we have to classify it. How to classify? So this is Q now, right? So this is Q. So this is Q is equals to x transpose into A into x. So therefore Q is equal to, this is Q is equal to. So according to classification, Q more than 0, Q less than 0, Q more than or equal to 0, Q less than or equal to 0, or Q is more than 0, Q less than 0. Such kind of expression, such kind of inequalities we have to calculate now. So now look at this, slightly modification. So Q is equals to x1 square. So this is plus 2 x1 x2 a square plus 2ab plus b square means x2 square I am writing. x2 square I want, so that I can write x1 plus x2 whole square, this one. But 5x2 square, here 1x2 square is over plus 4x2 square you get. Just I am adjusting the terms, nothing else. Same, these 3 terms only I am writing, but last 5x2 square I am writing as x2 square plus 4x2 square. And look at these 3 terms, first 3 terms I can write as, this one I can write as x1 plus x2 whole square I can write. Okay, and what is left? Plus 4x2 square is left. 4x2 square. Now look at 4x2 square. Yeah. So here the matrix X is column matrix X, which is x1 x2, right? And this is belongs to R2. Okay. R2, right? x1 x2 are coming for R, and this entirely belongs to R2. Now here we have to investigate whether it is more than 0 or less than 0, or more than or equal to 0 or less than or equal to 0. Whatever x1 x2 you choose for x not equal to 0, let me write here, for x not equal to 0, which x? This one. If this is not equal to 0 means what? x1 not 0, x1 not 0, x2 can be anything, or x1 can be anything, or x2 equal to 0. Overall x is not equal to 0. This is never 0, right? This is always positive. And x2 square is also always positive. So therefore this simply, so therefore for x not equal to 0, this x1 plus x2 whole square plus 4x2 square is always more than 0. When this has become 0, if x1 equal to 0, x2 equal to 0, x1 equal to 0, that means what I mean to say is if x is equal to 0 and 0, what I mean to say, that means x1 0, x2 0, substitute x1 0, x2 0, here also x2 0, then entirely will be 0. But what I want according to definition, for x not equal to 0, right? Go back. Look at this. All these are for x not equal to 0 only. Look at x not equal to 0 only, we have to look at x not equal to 0, x not equal to 0, like this. Okay. So therefore, we have to verify for x not equal to 0 only. For x not equal to 0, for x not equal to 0, we have to verify this sign. So this is always more than 0. And can you find a vector which is non-zero, such that this is equal to 0? For example, look at non-zero means, let me take 1 and 0. This is not equal to 0. X1 is 1, x2 is 0. 1 plus 0, 1 square is 1, and this is 0. So 1 I am getting. I am not getting equal to 0. Can you get equal to 0? Can you give such a x1 and x2? The only possibility is x1 0 and x2 0. Then only this expression value is 0. But can you give non-zero value such that this is 0? You cannot give such kind of thing. So therefore, what I can say, this is always more than 0. So therefore, what is the conclusion? So therefore, positive definite. Positive definite. So the quadratic form is positive definite. So this is the conclusion for this problem, first problem. Similar second problem, 1, 3 and 3, 1. Second one, let us take the matrix A is 1, 3, 3, 1. Okay, xy plus y square. So finally what you got, x square plus 6 times xy plus y square. Now go back, x square coefficient, when x is first variable, so a11 coefficient is 1. Look at 1. Next y square means y into y means second variable, so a22 coefficient is 1. So a22 coefficient is 1. Here look at matrix. Next x first variable, second variable, so that means a12 plus a21 is 6. Look at a12 plus a21 is 6, sum is 6, so it is correct one. So this is a quadratic expression. Now we have to investigate the sign of this one. So q, this one I can write x square plus 2 into x into 3y I can write, right? 6xy. It's like a square plus 2ab plus b square. In this format I am writing, so that I can write this one as a plus b whole square. Okay, like that I am expressing this one, x square plus 2 into x into 3y, so that 6xy I am getting. So instead of b you are having 3y, therefore this I can write 3y whole square, 3y whole square, right? 3y whole square is 9y square, but here y square is there. So 9y square minus 8y square, that's it, over. Simplify, we will get this one only. Look at x square plus 2x 3y plus 3y square is 9y square minus 8y square is y square only. Same this expression I am rewriting like this. Now these three terms together, these three terms I can write this one as x plus 3y whole square, okay, minus 8y square. Does it always positive or always negative? Now we have to investigate. Okay, so if you choose, look at here, if you choose 1, so if your capital X is nothing but small x and y, if this value is some 1 and 0 you take, this is non-zero, right? If you take this one, what is this value? Then what is q? Q value how much? 1, y value 0, so 1 square is 1, 1 minus 0 0, so 1. I am getting more positive. So if x is, if you take this one is some 0 and 1, which is again not equal to 0. Then what is q now? Now what is q value? 0 and 1. So 1 means 9, 9 minus 8, again positive I am getting. Can I get negative? Can you choose such values? Can you choose such values? So 1 here. So yeah, let us do minus 2 and 1. Yeah, you take this one. If just all these are just investigation, you have to verify like this, and the only thing is we have to find the sign of that. If I take minus 2 and 1 for example, which is again non-zero, what is q value now? Then q minus 2 and 1, x is minus 2 and y is 1. What will you get? Minus 2 plus 2, 1 square is 1, 1 minus 8, so minus 7 I am getting. So this is less than 0. So therefore sometimes it is positive, sometimes it is negative, so it is taking both. It is more than 0 and less than 0. So therefore if it is more than 0 and less than 0, what can I say about q? Q is indefinite. So therefore conclusion is, so therefore q is indefinite. Q is indefinite, like this. Similarly, you take this one as exercise, third one, verify same this one.